This is the start of Chapter 2. In this first section, we're going to talk about piecewise functions and an intuitive idea of continuity. Now I'm going to let you read the paragraph to yourself. It just lets you know that, hey, you know what functions are, and you've talked about using lines and parabolas and exponentials and things there. But this chapter, we're going to be looking at some of the piecewise functions at the start, and I'll explain what that is here in a moment. First thing here, let's look at a little warm-up. We're going to sketch the following graphs. These are all functions that we know how to graph. The first one, y is equal to 2 times the absolute value of x. And remember, your absolute value function makes that v shape. And typically, when it doesn't have a stretch factor besides 1, it'll just go up 1 and over 1 here. So I'm just kind of sketching what that parent graph would normally look like. But remember, this stretch factor, right, is going to like double our output there. So instead of going from 0, 0 to 1, 1, when we go over 1, we're going to go up 2. So it changes the slope of this side of the function. And the same thing on the other side. If we went back 1, instead of going up just 1, we're going to go up twice as much. And instead of going over 1, we're going to go up over 1 and then up 2 on that part. So it makes our v a little bit narrower for that function. Hopefully we remember that. For the exponential function, y is equal to 2 to the power of x. Remember, this is going to grow exponentially, and you're just going to continue to multiply by 2 more and more each time as you increase your input value. So if we just threw in here negative 1, we know 2 to the negative first power is 1/2. If we put in 0, 2 to the power of 0 is 1. If we put in 1, 2 to the first power is 2. And then let's just say we put in 2, 2 to the second power is 4. So notice that the output keeps doubling. So we could plot those points right on there. And remember, this one has that horizontal asymptote that runs along the x-axis. So this graph would come and then gradually start curving up more and more and more. And it shows you that exponential growth. The last one here, we have y is equal to the square root of x. Now we know our inputs can't be negative in here, so we'll start with that first critical point being 0. Square root of 0 is 0. When we plug in 1, the square root of 1 is 1. And then the next compatible value that we could put in there would be like 4. That would be easy to work with because the square root of 4 is 2. So remember, this one makes what some people call like that shooting star kind of shape, or parabola, half of it that's lying on its side there. All right, hopefully those help refresh how to graph some of those. Let's talk about what a piecewise function is. So a piecewise function is defined as a function that uses different rules for different parts of its domain. So remember, domain, we're talking about the input values, so all those x coordinates. Down here we have an example. It says let f of x, so that would be our function, and it has two different function rules here. Okay, so the one on the top here says it's going to follow that rule 2x minus 5 for all the input values when x is less than 3. So you think about it, so thinking about your x-axis here, remember here's where your x-axis is, and here is where 3 is. So for everything less than 3, right, when we plug in those input values, we're going to plug them into that rule 2x minus 5. And that's where you see that this line that is formed here, right? So all these are all the output values that follow this 2x minus 5 rule. And then for anything at 3 or greater, right, it's going to follow this rule here that looks like, it would be a parabola that is flipped upside down. Right, that was our opposite of x minus 3 squared plus 3. So all the inputs, if we plug in 3, 4, 5, 6, and so on there, right, we're plugging them into this function here, and then that's why the shape kind of changes, and that's why you see this shape where it goes down kind of like this here. You can see the half of the parabola. We'll talk about the shapes and everything here as we get into the next part. But key note here, this spot here where it changes, where the function changes the function rules here is what we call the transition point. That is going to be important to know. Let's jump into the first example. So it says graph the piecewise functions here. We've f of x is equal to, and we've got a 2x plus 3 when x is less than negative 2, and we have 1 minus x when x is greater than or equal to negative 2. So if you want to start out, one thing you could do here is you could say, all right, well, let's look at it as two different functions for a moment. We have y is equal to 2x plus 3, and we've got y is equal to 1 minus x. I'm going to flip it around and make it negative x plus 1 just because I prefer graphing linear functions in that form. All right, so I'm going to use a pencil, and I would advise you to use a pencil as well because you're probably going to do a little bit of erasing here until you get the grasp on things here. Now we know that our transition point is going to happen at negative 2, so I'm going to just kind of put a little marking here at negative 2, where x is negative 2. I'm not going to draw it all the way up and down the graph, but that's going to be that vertical line here, or that boundary where our graph will change its shape. So to start out, for everything that is less than negative 2, okay, we're going to be looking at this 2x plus 3. So if I wanted to just graph that line, y is equal to 2x plus 3, right? We have a y-intercept at positive 3. Our slope is 2. We're rising 2 and running 1. We're going to rise 2, run 1. And I'm just going to kind of sketch these points in here. Hopefully you can see them. I'll try to make it look like it was actually a pencil. Right? And so we'd have like this line that ran up like this. It's got a positive slope. However, okay, the only part of it that we're actually interested in, though, is going to be from where x is negative 2 and less. So we're going to take this here, and we are going to draw in. So negative 2 is not part of the domain for that part of the function. So we're going to put an open circle at negative 2, and we're just going to take it to the left here. So this is all of that shape that we're looking for. So in fact, you could take it then, if you wanted to, and just erase the original part of it there that you went up into that point there. So our transition point is where it's going to change directions, or it's going to change its shape. So we're going to look here at the second one. The y is equal to, or 1 minus x, or negative x plus 1. And this is going to start at negative 2 and be going to the right. Now we'll go ahead and sketch in all of it first, just so we can get an idea. So normally when I graph this function here, my y-intercept is at positive 1. And my slope right now is negative 1, so that means I'm going to go up 1, but back to the left 1. Up 1, back to the left 1. And so on. You can kind of plot them in there. And then down to the right. Now with this one here, we have the equals sign in it, so our point at negative 2 for this function is going to have to be a solid point because it's included in that domain. Now we don't need to graph the points on the left side here, we need to graph the points on the right side because that is where the domain is going. So, and if you want to then just erase any other extra points that weren't used there, this is what that function would look like. Okay, so we've got two lines, one that's going to the left at negative 2, excluding negative 2, but it's going, back down to the left, and then it's going down to the right from everything from negative 2 on. So it's following two different function rules here. For this underneath here, it says check on a graphing calculator. Well, I don't have an Inspire emulator to show you how to check it right now, so I may have to do that when I get back unless I can find a video and then leave it with the sub for you to look at. So let's just move on to the next one. Now we've got h of x is equal to, we have x squared plus 3 for everything less than 0 on the x-axis, and then we have the square root of x plus 3 for everything at 0 and beyond. So let's start here, first of all, with our y is equal to x squared plus 3. Okay, so I'm going to graph this one on there first. This is just a parabola that has been shifted up 3 units. This one should be pretty easy for us. Let's just go ahead here and put our vertex there at 0, 3. We go right 1, up 1, right 2, up 1, 2, 3, 4. And then if you think about it, I am plotting the whole thing on there, but the only part of it that we're going to use here will end up being that left side of it, right? Because our transition point on this one, where it's going to change directions, is at 0. Now, this one is just less than 0, so we're going to put an open circle right there, and then we need to make sure we still include our arrow on the other side. If you want to, then you can go back and erase those other points on the other side that you used to help graph it. For the second part of it, we're going to say y is equal to the square root of x plus 3. So this is like our square root function, but it has been shifted up 3 units. So instead of being started at 0, 0, we'd have to move up 3. So 1, 2, 3. So now we're actually on that same point. So that transition point, actually, we'll have to fill it in. I'm filling it in blue so we can see that that's the function that it's coming from. But then we would go to the right 1 and up 1, to the right 4 and up 2. And if we get it over to 9, we could go up 3, but it'd be somewhere out there. And then we just need to connect those ones. So, you know, everything on the right side here is the square root function. And everything back this way was the parabola. Okay, so a transition point there was where x equals 0. Now, if we wanted to, we could still treat this. This is a function. If we wanted to do inputs and outputs here, if you look down below, if we took our h of negative 3, so if we put negative 3 into the function, right, if we think about here's where negative 3 is, it would be, you know, we'd have to go up the graph way up here somewhere. Okay, well, we could also use the algebra part of it there. So since we know that negative 3 would fall in where x is less than 0, we will take it and do negative 3 squared plus 3 because it fits in that part of the domain for this function, which would be 12. So h of negative 3 is equal to 12. Now at 0, okay, so at 0, we're going to have to use the part of the function that includes 0, which is going to be the square root of x plus 3. So we're going to have to plug in there the square root of 0 and then plus 3, and that's going to give us an output of 3. So h of 0 equals 3. And then 16 would also fall into that part of the function's domain, so we're going to say the square root of 16 plus 3, which would be 4 plus 3, which is 7. So h of 16 is equal to 7. If you have questions, mark them there. You know, we're going to find a way to answer your questions when I get back. Next one. So if you think you're getting the hang of it here, you could take it and you could pause the video and try to draw it out there and then see if you get the same thing that I get when I do it here. With this one, we'll start out here. We're looking at y is equal to 2 times the absolute value of x minus 1. And that is for when our domain is less than or equal to 3. So thinking about 3 here, right? This is where our transition point should be on that line there. If we want to take it here, I'm going to sketch it in pencil first. So this graph is like our original absolute value graph, but it's been shifted to the right one, and then now it's got that slope of 2, so it's going to go up to, I'm sorry, right 1 up 2. And then it's going to go back 1, up 2, back 1, up 2, back 1, up 2. So now we kind of have that general shape on there, and we can take it and let's just connect our points until we get to that transition point, which is at 3. And in this one, we are including 3, so we will take it and put a closed circle there, or closed point. And that is the start of this function. Now, the other part of this function here is just where y is equal to -1. And that's where x is greater than 3. So that means we need to figure out where our y is equal to -1. And remember, that is all of the points down here along this line. I'm going to sketch it in pencil here first. Right, where y is equal to -1, that's all these points on this horizontal line across here. Right? So the points that we're interested in are where x is equal to 3. This is going to be an open circle. And then I'm going to extend it out this way. And you don't have to use different colors. I'm just doing it so you can see the different parts. Technically, it's all the same function. So we should probably make it all one color here. And then do not leave that extra part of it on there. That would be incorrect. So if you do draw it in there to find it and see it there, you need to erase it afterward. Okay? It is wrong if you leave it on there. So that is what this function would look like. Let's move on to the next one. So now we have 3 parts to this function. So this one would be like saying y is equal to, and I'm going to flip it around just for graphing purposes, -x plus 2 when x is less than or equal to -1. It'd be like y is equal to 3 from -1 to 3, and then it's y equals -2 from 3 to 7. So we're going to have 2 transition points here on this one. We've got at -1, there'll be a transition point, so I'm going to kind of put a little mark up there. We're also going to have one at 3. And then our function seems to stop at 7, so I'm going to take it here and actually put one down there at the very end there as well. So let's start out here. We've got y is equal to -x plus 2. So that's like a y-intercept of +2. And then I'm going up 1, back 1, because right, it has a negative slope. Okay, so the part that I need here would be at -1, 3 there, right? And then it goes up this way to the left. And I will actually erase that point on the y-axis there. Then we have from -1 to 3, so in between here, we've got that it's going to be y equals 3. So that's another one of those horizontal lines. So we already have a point here. So when we go across this way, we're going to go from -1 over here to 3, and that's going to be a closed point. Now ideally this is an open circle for this part of the function, but since we already have a point there from the left side of the function, that's okay. And the last part of it here, we have from 3 to 7, our y values are going to be -2. So we need to go down here to when x is 3, y is -2. We need to put an open circle here, and it's going to be a horizontal line until we get to 7, and then we need to put another open circle at the end. And it asks, can we check this in the calculator? We could if you knew how to do it there, and I would love to show you. I'm just going to need to find a way to do that there. But we will talk about that as soon as we can. All right, on to the next one. Oh, my bad. Before we get to that let's talk about intuitive notion of continuity. Okay, so we're going to talk about continuity later in the year, but for now, here's what I want you to remember. If we are graphing functions here, if you can take your pencil and you can graph the entire function, you can trace the entire thing here without picking your pencil up off the graph, we will consider that a continuous function. Okay, so here are two examples here where I can trace each of these functions and I never have to pick up my pencil to get from one point to another part of the graph there. So right now, just remember it's continuous there if you can draw the entire thing there without lifting your pencil. All right, we got one more example here. If you want to try it, go ahead and pause the video and then you can check to see if you are right. So the first function we have would be like y is equal to 2 to the power of x, and that domain is when x is less than 2. And the second part would be like y is equal to negative 2x plus 8, and that's from where everything is greater than 2. So notice our transition point, we don't actually have a point at 2. Okay, so they're both excluding the value 2 in the domain, but we will still need to go to that point before we shift directions. Go ahead there and start kind of plotting it there. Y equals 2 to the power of x. We know that's that exponential function. We have a point at 0, 1, 1, 2. And then I'll put one at 2, 4. And then we have one at negative 1, 1/2. Remember, this is where it has that asymptote that runs along the x-axis. So I'm going to just kind of sketch this guy in. And then remember, when you get to 2, that should be an open circle. Now the second part of the graph there is negative 2x plus 8. So I'm going to get my pencil back out. And I'm going to start at positive 8 there on the y-axis, our y-intercept there. Now remember, these points won't exist because they're on the other side of the transition point. But we'll go down 2, right 1, down 2, right 1. Oh, and we'll hit that point that our other graph started at there, but we're still going down 2 over 1, down 2 over 1, down 2 over 1. And now we can kind of sketch this one in. So remember, starting at the transition point on, and since we're excluding that value there, and go down to the right like that. So I forgot my arrow on the other side there. That will go out forever that direction. Now, is this one considered continuous? In this case, the answer would be no, because of that hole up in the graph at that point 2, 4 up here. If that was shaded in and we were including it there, then yes, it would be continuous. But no, this graph has a hole at x is equal to 2. And then they ask us to state the domain and range. All right, well, we've done some of these like this here, right? Our graph is broken into two parts. We've got all this part of the domain this way, and we've got all the domain on this side here, but we're excluding that value in the middle. So if we were going to write this out here, right, this is like negative infinity over here, all the way up to 2, but excluding 2. And then we're going to start at 2 and then go to infinity, right? So if we're going to write this out, we're going to say this is negative infinity to 2. And we're going to put a parenthesis. We're going to draw that U for the union, and then we're going to say from 2 to positive infinity, and then we're going to close it there. All right, hopefully this gets you started here. I appreciate you doing your best job while I'm not there. You could always go to Math Help during 4th, 6th, or 8th period there, or you can mark your questions, and I will do my best to answer everything as soon as I return. Thanks for watching. Good job, guys.